I'm Robin Higgins, and this is mole ratio versus molar ratio. All right, so this is really easy. They're the same thing. But what is that thing? That is the question. So let's take a look at a typical reaction. Hydrogen gas plus oxygen gas becomes water. So the first thing we have to do with this reaction is to balance it. In this case, we have two hydrogens here, that's fine. Two oxygens, only one oxygen, which means this has to be a coefficient of 2 to match this. And now we have to change the hydrogens to compensate. So we have to do 2 here, so we have a total of 4 hydrogens on both sides. All right, so now it's balanced. We can see that we have these different numbers here. So this is a 2. If there's nothing written, it's an implied 1. And this is 2 also. And so the mole ratio, or the molar ratio, is exactly what it seems like. It's the ratio of moles of one molecule to another. And you can really express it in any combination that you like. So remember, over here we have the reactants. And this is the product. So if we want to look at the ratio of water to hydrogen gas, well, it's going to be 2 to 2. We can reduce that, so it's 1 to 1. If we want to look at the ratio of water to oxygen, then it's going to be 2 to 1, and we can't reduce that. So this is the final molar ratio. But this is both products to reactants, but what if we do the products, or both the reactants? So we can do O2, ratio of O2 to H2, and it's going to be 1 here and 2 here. And again, we can't reduce that, so it'll be 1 to 2. So that's it. And just remember that you can reduce and that you can do it in any which way that you need to express either two reactants, reactants to products. If you have more than one product, you can do the product to products. It doesn't matter. And that these guys are the exact same thing. I'm Robin Higgins, and this is molar ratio versus mole ratio.